The SEED projects are 3 European-funded projects that research on software and solutions for exascale systems. Their goal is to improve the way that we operate and use our large-scale computing infrastructures in Europe. The SEED projects are continuing a long history of projects that were called previously the DEEP family, or the DEEP family of projects. The DEEP project, the first one, started in 2011, and it was the first time we decided to sit together with a group of partners in Europe to think how could we build heterogeneous supercomputers in a more efficient way. We proposed a system architecture that we called Modular Supercomputing Architecture, in which we try to combine the different kinds of computing of processing units in a system-wide way. So we put in one module all the CPUs, we put in another module all the accelerators, and these 2 large clusters, we couple them to each other. This enables to share those resources more efficiently between different applications. The SEED projects are 3 of them. So we have DeepC that takes care of the software stack and programming environment for heterogeneous systems, and in particular for modular supercomputers. So this is about the low-level software that is adapted to the different hardware entities, heterogeneous processing units, but also heterogeneous memory. Then you go upper into the programming levels and into the tools that help users to use all these complex hardware infrastructure, hiding a bit of this complexity. We have then IOC. IOC takes care of all the I/O and data management topics, because this is one of the main challenges in exascale computing, that you need in these very large systems to properly manage the movement of data, so that you are not wasting energy moving data all the time around. And last but not least, we have RedC that takes care of the development of advanced network interconnect for connecting both the components within the modules of a modular architecture, but also across the modules. And this is based on the BXI network interconnect, and it's about bringing new features, advanced features, more dynamic scheduling possibilities into the network interfaces. The first machine scheduled to reach the exaflop barrier in Europe is Jupiter, and Jupiter has been selected by Euro-HPC joint undertaking to be installed very soon in Jülich as the first exascale machine. This is a very important milestone. It's a very important milestone to demonstrate that Europe can have and can provide this important infrastructure to the users. But that's not the only thing. So it's also important to have technology development in Europe, so that it's not only deploying those machines, but also populating those machines with European technology. One important initiative in this context is the European Processor Initiative that develops the processors in Europe. Another important is all those projects as the SEED projects that are developing the software elements to operate those machines. So those are crucial. You cannot, having just the hardware is not enough. It's crucial to have all the software infrastructure and the applications prepared to use those. So these, I think, are the most important milestones. Deploy the hardware, being able to deliver the technology in Europe, and also the software stack and the applications to run on those machines.